Okay, so for this problem, we want to once again find a particular solution involving a trig function of sine or cosine. So first step, as always, is to go ahead and solve the homogeneous equation. So again, that's us solving y double prime plus 4y equals 0. We saw in the previous video that y1 of t is the cosine of 2t, and we saw that y2 of t was the sine of 2t. And you'll now notice that the sine of 2t, which is our forcing term, is a linear combination of these two functions. In fact, you could just take 0 of the cosines and 1 of the sines to accomplish this. So we have to make very careful decisions when finding our particular solution. And to do this, we're going to actually go and form our yp of t as an a times a t cosine of 2t times or plus a b times a t of the sine of 2t. It's very important to note that you have to make sure you put the t in front of both of the functions in your particular solution and not just the one that's repeated. So again, we have an at and a bt with our sine and cosine. Now we need to go through and take our derivatives, and these are going to be kind of hard because we have to use a product rule for both terms. So our first derivative is going to be the derivative of the first, which is a times the cosine of 2t, plus our first, which is going to be a t, times the derivative, which is negative 2 cosine 2t of the second. All right, so next thing to do is now take the derivative of the second term. Derivative of the first is just b times the second, and then plus the first times the derivative of the second, which is 2 cosine of 2t. Now you could actually take the derivative of this again to get the second derivative, but that's a lot of work. It's actually better to clean this up and make it simpler before taking another derivative. So let's rewrite our yp prime of t. And first look at the cosines. We've got 2bt of them plus a of them. So that's our new coefficient times the cosine of 2t. And I notice there's a typo there. Yes, the above function, looking at my derivative, that needs to actually be the sine of 2t right there. So let's go back and rewrite that as the sine. That is the derivative of cosine. So going through, we have the cosine of 2t there. And then now if we look at our sine functions, we've got the negative 2at plus our single b times the sine of 2t. And you'll always notice this kind of symmetry in your coefficients. You always have a linear function in front of both of them. All right, so now we need to take the derivative of this. Just going to be a little bit on the messy side. So derivative of the first is just 2b times the second cosine of 2t plus first 2bt plus a times derivative of the second, negative 2 for some reason it's not writing there, negative 2 sine of 2t. And now we'll take the derivative of the second term. Derivative of the first is negative 2a times the second plus first times the derivative of the second. And then just like before, let's go through and clean this up. So if we now look at our cosine terms, we're going to have 2b of them here, and then we're going to have a 2 times negative 2at and a 2b there. So adding all that up, we're going to have a negative 4at plus 4 times b. Again, that's all times the cosine of 2t. And now the same thing for the sines. We're going to have a negative 2 times 2bt makes a negative 4bt. And then we're going to have that negative 2a getting together with the other negative 2a to make negative 4 a. And again, this is times the sine of 2t. All right, so this now needs to get substituted into our original inhomogeneous equation. And yes, this is very long. So putting in the yp double prime, we've got negative 4at plus 4b times the cosine of 2t plus our negative 4bt minus 4a sine of 2t. And then our equation has a plus 4 times the y, which is a t cosine 2t plus bt sine of 2t. And that must all equal out to our forcing term, which is the sine of 2t. Well, if you look very carefully, you'll notice that our negative 4at and our positive 4at in front of the cosine function are going to cancel out. And you'll also notice that the negative 4bt and the positive 4bt in front of the sine function will also cancel out. So all that's left is going to be a 4b times the cosine of 2t and that's going to be then with a minus 4a sine of 2t, and that's equal to the forcing term, sine of 2t. If we now compare cosines, we've got 4b matching up with nothing. So 4b equals 0, means b equals 0. And we see that negative 4a must match 1. So negative 4a is equal to 1. So a is negative 1/4. So since we're out of space here, let's just kind of write our solution. Our yp of t is going to be negative 1/4 t cosine of 2t. And then our general solution is going to be the c1 cosine 2t plus c2 sine of 2t plus our particular solution minus 1/4 t cosine of 2t. And you will notice that we once again have three linearly independent functions. We have a cosine of 2t, sine of 2t, and t cosine 2t.